Welcome to the Deep Dive. We take a whole pile of sources, research, all that stuff, and, well, we boil down to what's really important, what's surprising, maybe just plain interesting. The idea, like always, is to give you a shortcut, get you properly informed. Today, we're jumping into something that feels super relevant. Human deception. We're going to use it as a lens, actually, a way to look at something, well, much bigger, how AI is trying to find this kind of universal grammar, something that shapes, I guess, everything.
That's a great way to put it. Yeah, our mission here is to unpack how AI tackles this idea of a universal grammar. These sort of fundamental rules structuring reality. Could be anything, really. Biological evolution, the ups and downs of the stock market, and yeah, definitely how we interact, how we communicate. And human deception. It's actually a perfect test case for AI to learn this grammar, because think about it. A lie is basically a measurable deviation from truth. By spotting these deviations, AI starts to get a handle on what truth itself looks like. And what's really cool is how this same idea stretches way beyond just telling fibs. The same kind of analysis that spots a fake alibi. It could spot dodgy financial transactions or political propaganda, or even, how animals use camouflage in nature. It hints at this like fractal pattern thing we're going to explore.
Okay, wow. A lie is a deviation. Let's dig into that. If it's a deviation, how does an AI actually see a lie? Because let's be honest, humans are pretty bad at it. It's not gut feeling, right?
No, absolutely not gut feeling, not intuition. It's pure high-dimensional statistical analysis. Think of it like this. You or I might look for maybe one clue. Someone fidgeting, maybe. An AI. It's looking at thousands of tiny, almost invisible things all at once, creating this complex fingerprint, you could say, of truth versus deception. That's the high-dimensional bit. It builds a mathematical picture of truthful talk and then finds these subtle but statistically real shifts away from it. You could almost think of it like a deception tax on the brain. It costs something, cognitively, to lie, and that cost shows up in language. AI uses NLP tools, natural language processing, things like LIWC, that's linguistic inquiry and word count, and NER, named entity recognition. They're not just jargon. They let the AI apply psychological theories in a practical way.
So it's not the lie itself, but maybe the effort or the lack of detail that comes from making stuff up. That's clever.
Right.
What are some of those specific linguistic fingerprints it hunts for?
Exactly. So one big theory is reality monitoring. The idea is that made-up memories, they just don't have the same rich sensory detail as real ones. Like, try inventing the exact smell of the beach on your fake vacation. It's hard. Real memories have that richness, even faint ones. AI notices when it's missing. Then there's cognitive load theory. Basically, lying is hard mental work. That's why liars might trip over words, use simpler sentences. Their brain is busy juggling the lie, so adding complexity is just taxing.
Okay, so what does that look like in practice? Specific words, sentence types?
Right. So for instance, people telling lies tend to use fewer first-person words like I, me, my. It's like they're subconsciously distancing themselves. You might see more third-person words instead. Also, often more negative emotion words: hate, worthless, sad, maybe guilt, anxiety peeking through. And because it's mentally demanding, they often use fewer exclusive words, things like except, but, without. Those words signal complex logic, which is tough when you're making things up. Narratives tend to be less structured, fewer specific details. Interestingly, how much they talk. Well, the research is mixed. Some studies find liars say less, others find they say more, maybe overcompensating, and sometimes you see really convoluted sentences trying to dodge a direct answer.
Okay, this is where it gets really interesting for me. If AI can spot these tiny cues, how good is it compared to us? Compared to humans?
Yeah, the difference is pretty stark, actually. Studies show machine learning models hitting around 69% accuracy just with linguistic features, and up to maybe 77% if they use a wider range of NLP tools. Now, compare that to human judges, even the experts, people trained for this. They only get it right slightly better than flipping a coin, about 54% to 59% accurate.
Wow, okay, 54 versus like 77%. That's a huge gap just based on word choice. So words are one thing. But what about body language? We instinctively look for that, right? Shifty eyes, fidgeting, even though we know it's not reliable. How does AI do with nonverbal cues? Can it make sense of all those fleeting movements?
This is where AI really goes beyond what humans can do. It uses high-frequency, multi-channel analysis, so computer vision systems. They can spot incredibly subtle things. Micro-expressions, these flashes of true emotion that last less than a fifth of a second. Eyebrow movements, lips pressing together, even tiny wrinkles appearing. It also tracks eye movements where you're looking, pupil size changes. And there's one really interesting pattern. Often, blink rate decreases right when someone is telling the lie that's cognitive load again, and then it shoots up right after they've said it.
That is incredibly specific. And I guess The best systems aren't just looking at one thing, they're pulling everything together.
Exactly. The most advanced systems use what we call multimodal fusion. They combine data from text, audio, think vocal stress, pitch changes, tone of voice, video, obviously body language and facial stuff, and sometimes even physiological sensors. Heart rate, skin conductance, things like that. And often the real giveaway, the strongest signal of deception, it's not one single cue, it's an incongruity between the channels. Like someone says calm words, but their voice sounds really stressed. That's a big red flag for the AI.
Okay, that sounds incredibly powerful.
Yeah.
But I've seen some reports claims of AI getting near perfect scores with all this data. 90%, even 100% accuracy. Is that real? Can we trust that?
Right. This is super important and needs a big caveat. Yes, some studies report these amazing accuracy rates, 90%, sometimes even higher, but often this is down to, frankly, poor methodology and something called overfitting. See, when you add more data types, text, audio, video, sensors, you massively increase the number of features the model looks at. Now, if you test this on small data sets that get reused a lot, there's one famous one with only 121 video clips. It's really easy for the model to just memorize weird quirks in that specific data set. It's not learning general patterns of deception. It's learning the noise in those 121 clips. So those nonverbal cues that might actually be quite faint or unreliable in the real world, they can look perfectly accurate because the model just memorized them for that small set. It doesn't mean it works outside the lab.
Okay, got it. So AI is definitely better than humans, but we need to be skeptical about those super high accuracy claims. Which brings us back to us. Why are we humans so bad at this? What does that big difference tell us about ourselves?
Yeah, it tells us quite a bit about our human baseline, actually. The biggest factor is probably something called truth default theory, TDT. It basically says our default setting as humans is to assume other people are being honest. This truth bias isn't really a flaw. It's essential for society to function, for communication, for cooperation, but it does make us vulnerable to being duped. AI doesn't have that social programming. It just looks at the stats, no default trust assumption. Plus, we humans get easily overwhelmed trying to track multiple clues at once, especially if they contradict each other. We have limited brain power for this, and we fall back on unreliable stereotypes, fidgeting, looking away, all that stuff. And AI, it can analyze hundreds of things simultaneously. No fatigue, no bias toward stereotypes. It just sees the subtle patterns we miss. It's kind of a profound trade-off, isn't it? The very way our brains are wired for social connection makes us relatively poor lie detectors.
That is a really profound trade-off. Our social default makes us vulnerable. Changes how you think about it. Okay, but just getting a yes-no answer, lie, or truth, that's not always enough, is it? Especially if the stakes are high, like in court or something. How can we trust an AI if it's just a black box and doesn't show its reasoning?
Exactly. And that's precisely where explainable AI, or XAI, becomes so crucial. XAI is all about making AI transparent, helping us understand why it reached a conclusion. The goal is to move AI from being this sort of oracle that just gives answers to being more like a transparent partner in analysis.
So how does XAI actually change that simple lady truth output into something, more useful, more trustworthy?
Well, it turns that binary verdict into a detailed, evidence-based report. And that shift is huge. Think about it. Just saying a lie is an accusation. It shuts down conversation. But a report that says, hey, we noticed these specific communication patterns, maybe fewer sensory details, higher vocal pitch that can start a conversation. It lets a human look deeper. Maybe the person isn't lying. Maybe they're just a bad storyteller or nervous. It really shifts the AI from being a lie detector to being a communication analysis tool. Much more helpful.
Could you give us an example? Like, what would an XAI report actually look like in a deception case?
Sure. So you might use a technique like LIME that stands for Local Interpretable Model Agnostic Explanations. It could highlight a specific statement and say, flagged due to high use of negative emotion words, low first-person pronouns, and simple sentence structure. Or another method, Shapley additive explanations could give you a confidence score, say 72% deceptive, and then it would break down why. Key drivers, use of the word hate added 15% to the score, low self-reference added 12%, high vocal pitch added 10%, but complex sentences reduced it by 8%. You can even get visuals like partial dependency plots showing globally how, say, increasing sensory words makes the AI less likely to predict deception, and it gives you the breakdown.
Okay, that level of detail definitely helps build trust. But it makes me wonder, can we trust the explanation itself? Could the AI be, faking its reasoning?
Yeah.
Giving us a nice story that isn't actually why it made the decision? Yeah.
You've hit on a really tricky, almost recursive problem. Can we trust the explanation of the explanation? And yeah, some research shows models can sometimes generate plausible-sounding reasons that don't perfectly match their internal workings. Unfaithful reasoning. they call it. So true trust doesn't come just from XAI tools alone. It needs more. It needs XAI plus really rigorous testing of the model, ongoing monitoring of how it's performing, and always, always strong human oversight. The aim isn't blind faith in the AI, it's well-calibrated skepticism, informed by transparent evidence.
Okay, so we can detect lies with AI. We can understand why thanks to XAI. How do we actually build systems that use this power responsibly? How do we go from just knowing deception exists to actively protecting ourselves or making better decisions?
Right, this gets into the framework for human-AI collaboration. And step one is designing interfaces we can actually trust. The AI's output should never look like a final, certain fact. The interface needs to show uncertainty, probability, give confidence scores. 85% confidence of deception, maybe a probability range. Explanations should be layered. A simple alert for linguistic inconsistency detected, but let the user click to drill down into that detailed XAI report if they want. And the design has to be useful, but not annoying. Clear next steps, maybe non-intrusive notifications or a dashboard view, and always giving you, the user, control over privacy settings.
So the AI is like a quiet advisor, offering insights but letting you investigate further. What would a whole system using this look like in practice?
We could imagine something like a Sentinel system, maybe drawing ideas from cybersecurity models like Zero Trust. This system would pull in data in real-time emails, chats, maybe video calls, and analyze them. AI would help triage, sorting potentially low-stakes white lies from high-risk deception that needs attention. Applying those zero-trust ideas means no communication gets a free pass. Everything is analyzed based on evidence, not assumptions. And critically, all this needs strong rules around it. Governance, policies for acceptable use, data handling, accountability. Importantly, such a system isn't making the final call. It's acting more like a cognitive prosthetic, giving you superpowered evidence to inform your judgment. The human is still in charge.
A cognitive prosthetic. I like that framing. But liars adapt, right? Deception tactics change. How do these systems keep up? How do they avoid becoming outdated?
That's a crucial question, and the answer lies in the learning loop and having a human in the loop, or HITL. You're right, deception patterns evolve. It's called concept drift. So the system needs constant feedback. You, the user, need simple ways to give feedback on alerts, a quick thumbs up, thumbs down. That creates high-quality labeled data for retraining. The system can also learn implicitly. If everyone keeps ignoring a certain type of alert, maybe that alert is generating too many false positives and needs adjusting. It creates this virtuous cycle. Flag tricky cases, human reviews them, feedback gets collected, model gets retrained regularly.
So it's this ongoing cycle of AI analysis, human feedback, and system improvement. But scaling this up sounds like a massive effort. Is there a hidden cost here?
Oh, absolutely. You're right to point that out. Rolling out something like this widely introduces a kind of new society-wide deception tax. Think of the huge computing power needed for constant monitoring, the human effort required for that HITL feedback loop. And even for individual users, there's an added cognitive load constantly evaluating AI alerts. It really signals a fundamental shift, isn't it? Moving from a world that largely runs on trust by default to one that might lean more towards verify by default.
That's a huge shift. Fascinating. Okay, so if AI is good at spotting deviations in human chat, what other kinds of deceptions or anomalies can it find? Does this idea of spotting deviations from a baseline go further, maybe connect back to that universal grammar idea?
It absolutely does. That core skill, finding meaningful whittles from a stable pattern, is incredibly versatile. Deception seems almost fractal. It pops up everywhere. Look at biology. Simple camouflage or mimicry, that's first-level deception. An insect looks like a leaf. That's directly analogous to AI spotting a phishing website pretending to be your bank. Then you get more complex stuff, tactical deception, like a bird faking a broken wing to lure a predator away from its nest. Even plants do it. Orchids that trick insects into pollinating them by mimicking food or mates but offering no reward. There's even a plant genus, Erycema, that practices lethal deceptive pollination, trapping pollinators inside. A pretty stark metaphor for how widespread misinformation can poison an entire information ecosystem, right?
Wow, from phishing sites to lethal orchids. Okay, so what about deception closer to home? In our institutions, politics, finance, seems like prime territory for AI.
Definitely. In politics, for example, propaganda often uses very specific linguistic tells. Lots of emotion, logical flaws, endless repetition, few checkable sources. AI can spot these patterns. It can also identify coordinated, inauthentic behavior, think bot farms, pushing the same message across social media. But, and this is a big but, it's created a dangerous arms race. The same AI models, the large language models or LLMs that are used for detection, they're also incredibly good at generating convincing propaganda. And they can tailor messages to individuals based on their online data. So it's AI fighting AI now. In finance, fraud detection is a more established AI success story. Fraud is basically an anomaly, a deviation from your normal transaction pattern. A huge purchase you never made, a login from a weird place, complex money laundering attempts. AI is brilliant at spotting these anomalies in vast data sets, scoring risk in real time, and finding complex fraud rings.
Okay, so it's great for finance, but in politics, it's an arms race. What about schools? Academic integrity. With students using AI like ChatGPT for essays, are AI writing detectors the solution there?
The AI writing detector issue. This is actually a really important cautionary tale about AI detection. Yes, generative AI creates new challenges for academic honesty, but the tools built to detect AI writing, they are notoriously unreliable. They throw up way too many false positives accusing human students of using AI when they haven't. Even major companies like Turnitin have admitted this is a problem. And worse, the research we looked at shows a disturbing bias. These detectors are significantly more likely to flag writing by non-native English speakers or neurodivergent students. Their perfectly human writing style might just look different enough from the AI's training data to trigger an alert. The potential harm here, the immense human cost of a false accusation, is massive. It can wreck a student's academic career, cause huge stress.
That is a serious problem, especially the bias aspect. So why the huge difference? AI seems to work well for spotting financial fraud, but it's unreliable, even harmful, for detecting AI writing. What's going on?
This contrast really highlights a core principle. AI pattern detection works best when there's a strong signal-to-noise ratio. Financial transactions, they have a clear, stable baseline pattern. Fraudulent activity is usually a big, obvious deviation, a strong signal against low background noise, easy for AI to spot. Human writing, though, it's incredibly varied, messy, unstructured. There isn't one stable baseline. The subtle differences between human writing and the text from advanced AI, that's a very weak signal buried in a lot of natural human variation, high noise, makes reliable detection incredibly hard. So you can use this signal-to-noise idea to predict how well AI might work in any new area. How clear is the pattern? How much noise is there? And this whole back and forth deception and detection, whether it's animals evolving camouflage or AI developers building better detectors and generators, it suggests deception isn't just something intelligence does. It might be a fundamental driver of intelligence evolving in the first place, pushing things to get smarter, more robust.
That constant push. Okay, this leads us straight into the deep end, the societal impact. If we could build a perfect truth machine, should we even want to? What are the big risks here? The ethical minefields.
Yeah, this is where it gets really complex, ethically speaking. First off, bias in the code. AI learns from data. If the data used to train a deception detector overrepresents certain groups and its examples of deception, the AI could wrongly learn to associate that group with dishonesty, leading to really unfair, discriminatory outcomes. Then there's privacy, huge privacy risks. To work well, these systems often need access to very sensitive data, our conversations, maybe even biometric data. That opens the door to mass surveillance, data being misused. It's been called an ethical catch-22. The very data that makes the tech effective also makes it deeply problematic without strict safeguards.
And what about mistakes? If an AI wrongly flags someone or misses a real deception, who's responsible when it's basically a black box?
That's the accountability problem. When complex AI systems mess up, it's incredibly difficult to pinpoint blame or figure out how to fix it or how someone gets recourse. So, tackling these risks needs both technical fixes, things like bias audits during development, anonymizing data where possible, keeping clear logs of decisions, and strong governance. That means things like human-in-the-loop oversight, clear legal rules about AI harms, maybe specific laws for synthetic media like deepfakes. And we have to remember the deceiver's new tool. Generative AI is already being used for sophisticated scams, phishing, voice cloning for fraud, and political manipulation with deepfakes and bots. The future probably isn't a world without lies. It's likely a world with more sophisticated, more scalable lies, fought in this constant, high-stakes tech battle between AI detection and AI generation.
Okay, so after this really deep dive, we've seen the power of AI for finding patterns, especially decoding deception. But what's the main takeaway, the critical lesson here?
I think the biggest lesson is that the idea of an infallible machine, a perfect lie detector, it's a dangerous fiction. That academic integrity example is such a stark warning. Using unreliable, biased, opaque AI for high-stakes decisions can cause profound and unjust harm. In that case, the difference between AI and human text is just too weak, the potential for bias is too high, and the human cost of getting it wrong is simply too great.
So for you, the listener, what does this mean? It means the real value here isn't about replacing human judgment. It's about augmenting it. Think of AI as this incredibly powerful microscope. It reveals hidden patterns, gives you transparent evidence to consider, but it's not an oracle telling you the absolute truth.
Exactly. The goal should be a symbiotic understanding of patterns. We want a future where AI is a genuine partner, a partner that equips all of us with better insights to navigate this incredibly complex world, hopefully with greater wisdom, maybe deeper understanding, and definitely more discerning critical judgment, the learning, the critical thinking. That journey continues, even with powerful AI by our side.
This is DigitView.